Hey there, we're back now for Chapter 4, Section 2, which is going to be the little bit of algebra that we get in our course. It's the least squares regression line. All right, so the first thing we're going to talk about is finding the least squares regression line and using it to make predictions. So we have a lovely display here of the same data that we saw before online. It's the fertility rate, i.e. the births per woman, and the life expectancy for those years, and this is 1962. Remember, that was the year they had the third world phrase coined. So there's the third world over here, there's the first world over here, and I have Excel to make this graph, and Excel would give me these equations. We'll talk about how that does that in a minute. So your first mission in life is to find the value of the correlation coefficient. I'm going to need Excel open. There. Not because I really need it for doing this, because it's not like we have the data or anything, but I just want it to do the calculation for me. So you can see that you have this r squared value, but remember r is the correlation coefficient, so you just need to take the square root, SQRT, of 0.5803. There you go. Now, the interesting thing about this is that when you take the square root, it could be positive or it could be negative. So you have to look at the picture and figure out that it must be, in this case, negative because this is going down. So for our purposes, r is equal to negative 0.76, oops, I think that was 762. Let me go back. Yep, 762. All right, what does that tell us about it? That's a moderate negative linear relationship between births per woman and life expectancy. Good. Okay, so suppose that in 1962 a country had a fertility rate of 4.207. Use the linear equation given on the graph. What would we expect the country's life expectancy rate to be? Okay, so the linear equation, if you've ever been in an algebra class, you've learned y equals mx plus b. There it is, y equals mx plus b. So that's our equation. I really don't need it underlined. All right, but instead of x, for us, x is this fertility rate. That's our explanatory variable. So they're telling us this country had a fertility rate of 4.207, so I'm going to put 4.207 in here. All right. Now, I need to know what that is. And again, I'm just using Excel. This isn't really needed on a... Oh, I should have labeled these. Oh, this was 4.1 example something. Well, let me go find out what example it was. There we go. It was example 6, so I better label that. That's not good. And then, honestly, I'm doing grunt work here, but, you know, I can put it in here. This is 4.2. I just call it 4.2 examples or something like that for right now. Okay, so I found r, and then I just want to find this value. So it'll be equal to, I gotta remember what the equation was. Oops. Sorry if you can hear my mouse scrolling. There it is. Okay, so negative. And how I do this, by the way, notice how I make the window kind of smaller so I can still see what's happening on this sheet, but I can still write in Excel. That's what you can do when you're taking a test. So if you're, oops, yes, that's fine. It likes the times. So if you're sitting there and not the face-to-face test, but for your online tests, if you're sitting there working on a problem, you can have Excel open and then just kind of make it open in a smaller window. And then you can kind of maneuver it on the screen so that you can still see the data or whatever you're trying to calculate and then come back here. So 61.37. There we go. Okay, so that was the country of Gabon, which is in sub-Saharan Africa, had a birth rate of 4.207 and a life expectancy of 40.387. This should say years. These are years. Okay. In 1962. Compute and draw and label the residual, i.e. the error on the graph. Okay. So error, there's different kinds of error, but this particular error is called a residual. It's going to be your observed y minus your predicted y hat, right? Because when we're doing this, we're technically finding a y hat. Little prediction. Okay, so we want the residual is equal to observed minus predicted. All right, that is equal to, we observed in real life 40.387. Oops. Well, I suppose if I'm doing 3 decimal places there, I should probably do 3 decimal places with the other one. 366. Let me do that. 366. All right, so minus 61.366. And again, I'm just going to make Excel kind of help me out with this. So residual is equal to 40.387 minus that answer. There we go. So it's 979, so negative 20.979. All right. Okay. Now that we know about this residual, this particular residual being negative, I want to talk about a little bit about negative and positive residuals. So if you have negative residuals like we do in this particular case, that means that the real life value that we observed is lower than what we predicted from the model. Right? So this is a quick drawing of this, but I only have this particular dot right here, the 4.207. I have him colored in green. Or, yeah, I made it green. Yep, green. And then up here on the line, there's a dot. You don't see it, but there's a red dot. That's what we found, right? And then there's a distance between them. The model, which is that line, is way over what we actually had. So the model overestimated, right, what we actually were going to get. Right? Now, if it's a positive residual, it's the opposite, right? So if you have a positive residual, you observe something that's up high, and then you predicted a value that's lower than that, right? And so therefore, you underestimated what was going to happen. So it's a little weird because negative actually means overestimate and positive actually means underestimate. And that's because the estimate isn't as important to us as the actual value. All right, so what's going to happen? I only picked out 2 points. I picked that one, and I think I picked this one over here, right? So I chose those two as kind of, I don't know how to describe it, numbers to think about, right? Now, what about all of them? Like if I could get the residuals for every last one of these 192 countries, right, what would happen? Well, if I added them up, they'd make 0, but the best line is going to be the one that makes those errors as small as possible. I want these numbers to be as little as possible. I want the residuals to average out and be small. We don't want a lot of error. Okay, so regular residuals will always add up to 0 because they're going to have your positives and your negatives. So we square them to turn them all positive, and that's what we minimize. So the computer minimizes the square of the residuals because just like with when we did standard deviation, remember we found the deviations and we squared them to turn them positive. That way the pluses and the minuses wouldn't cancel each other. The same thing's true here. So we square the residuals to turn them positive. Well, we don't do it. The computer does it in the background. But it squares all the residuals to turn them positive, and then it minimizes them. So that way your line is the line that has the best fit. It's the line that has those residuals, those errors, the smallest they can be. That's why it's called the least squares regression line, because it squares the residuals and minimizes them to the least they can be, the least value. I will also call it all sorts of things. The least squares line, the linear regression line, the line of best fit, the linear model, the line. Because there's only one line that's the best line, and that's what the least squares regression line is, and that's what your computer will find for you in both Excel and StatCrunch. Okay, but it's dealing with the squared residuals, that's why it's called least squares, right? But it's going to make them small. And that's important because you don't want a ton of error. The best line will be the line that doesn't have a lot of error. Okay, so I have our Sandusky free reading passing math tests. And I'm going to, what example is this? Example 2. Okay. So I just did a little work here. This was, I guess, example 1 to be fair. So I can change it from examples to example 1. Because I'm going to put the free reduced lunch thing on another path. I'm going to put it over here. I know we did parts of it already, but let's do it again, because we're going to do it a couple different ways. Okay, now if you have some enhancements to Excel, if you have the data analysis tool pack, then you can do this a different way, and I know that, but I'm not going to do it that way. Okay, so the first thing I'm going to do is I'm going to show you how to make a scatter plot. So you highlight the stuff, you go to Insert, Scatter, Scatter Plot, and then I've got this stuff, right? And this is reading, or no, sorry, this is free lunch versus math scores, math pass rates. Okay, beautiful. Now when you do that, you can right click on the dots, choose to add a trend line right there, linear, and then down here at the bottom you want to display the equation, and it doesn't hurt, display the r squared on the chart as well. Close. And then you can pick up that box that they're in and move them around to see them better. And there you go. So that's one way to do it. Now let me show you another way. If you want the slope and the y-intercept, right? Because that's, remember your y-intercept is b, your slope is m, and y equals mx plus b, right? So slope, you can type equals slope. That's actually a function. Now notice it goes weird. It puts the y's in first and then the x's. So you highlight your y's, comma, highlight your x's. Close parentheses. There you go. Notice this is the same number that we found over here. Y-intercept, you have to type intercept. There's your y's, comma, there are your x's. Close parentheses. There you go. So you've got those pieces. Oh, and the other one we need to know how to do is StatCrunch. So that's the two ways to do it in Excel. Oh, and just as a side note, remember R, we found it's the correl. Just, it's a little review, but that's okay. Array 1, now this one goes the other way, 1, comma 2. You can tell this was not done by teachers. Teachers would not have done it like that. Okay. And then you would just write out your equation. You'd say, oh, it's y equals negative 0.2826 x plus 69.108. Boom. Now, if you're in StatCrunch, it's a free program. You might as well use it, and it's awesome. Here's StatCrunch. So I'm going to paste my data in. And I go to Stat, Regression, Simple Linear. It's the same thing we did to do correlation, to be honest. There it is. Then I tell it my x variable is free reduced lunch. My y variable is passing math. Next. Don't worry about this. Ignore it. If you want to look at your residuals, you can click Save Residuals, but don't worry about it. Click Next. If you want to plot, you can click Plot the fitted line. Next. Ignore. Calculate. And there you go. Copy. And let me bring it in here. Whoops, not there. And paste. I'll put it wherever I want. And you can see the intercept right there and the model. Boom. You can also see it right here. It's the same thing. 69.1, they just wrote it backwards. 69.108 minus 0.282 times x, right? So they're writing the opposite of this. That's fine. That also works. So you get it a whole bunch of different ways. Actually, I'm going to color these differently. These were the stepping stones to come up with the equation. So those are orange, but the answer is actually the yellow part. And just in case you didn't notice, there's the correlation coefficient right there. All right, so let's go copy and paste those suckers in. So again, notice this is, they're just writing out the letters. So y, which is your passing math, is equal to 69.108 minus 0.282 times x. See the x in there? All right, and then they're telling you out x's. I personally like the way I typed it, so I'm going to copy and paste that in. All right, we're done with finding the line of best fit. We'll meet back here next time to use that line to answer some questions. See you then.